already, or rather I have already introduced to you the 4 different types of congruency tests. So the 4 different congruence tests that we have is number 1, SSS test, 2, SAS test, 3, AAS test, and 4, RHS test. Okay? So I want to look at practice now 3 now. Question 1. So in question 1, we are given ABCD being a rectangle. The diagonals AC and BD intersect at O, and we are given that angle BAC is 25 degrees. In part I, we want to prove that triangle AOB is congruent to triangle COD. Okay? So yesterday I mentioned the different way that the question can be asked. So when they ask you to prove that they are congruent, surely they are congruent. We just got to apply the test. Okay? So triangle AOB refers to this one here. And triangle COD refers to this here. Okay? There are many ways for us to actually prove these 2 triangles to be congruent. So let's just maybe have the triangles out side by side to visualize the problem. So we got an O here, A, B, 25 degrees. And then, because question says AOB, right? So it must be COD. Okay, and then we know CD has the same length as AB. Okay? So how should we go about proving the congruency? We usually start off with writing what is already obvious to us. Okay? So what's the very first thing that we can surely use, or we should use? What do you think? Noi, what do you think? What is the obvious thing between these 2 triangles that you can already write? Okay, so we will write AB equals to CD. So we got one side already now. Okay? Then then the other information we will have to actually go on deriving it. Alright? So what can we actually derive? Yes, Joseph. Angle BAC is equals to ACD because they will be parallel because why? Yes, because it's a rectangle. But more importantly, the angle property that we're using is alternate angle. Okay, Z shape. Right? So we know that this angle here is 25 degrees. Okay, so we will say that instead of saying BAC, follow the ones given in the triangle itself. So we say angle BAO equals to angle DCO, which is 25 degrees due to alternate angles, parallel lines. Okay? So at this juncture, we say that we already have one side and one angle. Okay, that reduces us to be using either test number 2 or test number 3, because only these 2 tests has the discussion on one side and one angle, right? Okay, so we need to find either one more side that makes this 25 degrees an included angle, or else we need to find one more angle. Okay, is there a way to do either one of this? What would you think? Without any ideas? How will we be able to derive out the equivalence of one more side or the equivalence of one more angle? If I use one more side, that means I must have AO equals to CO. AO is here, CO is here. Do you know anything about these diagonals in a rectangle? Okay, so they should be the same, but why? I agree with you, AO equals to CO. But why is it the same? Because you measure? Or because it is a property of something? Joseph, what do you think? Sorry? Midpoint is O, okay, alright. But more importantly, as a recap about properties of rectangles, okay, the diagonals actually bisect each other, so a property of a rectangle. So diagonals bisect each other. In fact, in a rectangle itself, diagonals are equal in length. So let me elaborate a bit. Okay. Regarding the diagonals that bisect each other, this is for any parallelogram. Okay. Regarding diagonals being equal in length, it is, hang on now, also applying for any parallelogram. Yeah. Okay. So this property is not limited to just a rectangle. It applies to any parallelogram itself. Okay. So therefore, I can say that this and this length is actually equal. Then after that, this length and this length is equal as well. Okay. And in the rectangle, actually, diagonals being equal in length. Sorry, let me think for a moment now. Parallelogram diagonals are not equal, right?
Yeah. There's one I forgot the name.
Yeah, sorry. This one, not all only for rectangles and squares. Trapezium is not a parallelogram. For diagonals to be equal in length, it is only limited to just the rectangle and the square. Okay? It is, rhombus cannot. A general parallelogram also cannot. Okay? So actually all these are actually equal in length. So AO equals to CO. How to actually explain this? We say that it is the property of rectangle. Okay, so if you want to prove it in this manner, we can use SAS test to say that triangle AOB is congruent to triangle COD using the SAS test. Okay. What if I want to use AAS test? How? So I have this and this. I need one more angle. Okay, so because just now earlier on we said that the diagonals in the rectangle they are equal in length. So AC is equals to BD, and the fact that they bisect each other, so AO, BO, CO, DO, they are going to be the same angles. That makes it the case that we have isosceles triangles, and then after that we get 25 degrees here and 25 degrees here. Okay, so we can have these two angles to be equal. Then you know it will be a bit lengthy in terms of the answer. But then, if I want to shorten the answer and use A as test still, I can actually say that these two angles are equal. And why would they be equal? Yes, we can say vertically opposite angles, right? So that may actually be shorter. In a rectangle, there are many ways for us to prove it. In fact, I can also say by SSS test, if I don't want to use the angles, because after all, diagonals being equal in length, we have isosceles, we have also the diagonals bisect each other, end up all the parts of the triangle are equal in length. Since this will be equals to this is equals to this, and then down here they are equal, we got corresponding sides, and we can then use SSS test as well. Okay, then after that in part 2, we want to find out what is angle BDC. So BDC is this angle here. Okay. So actually using just now my explanation, since OC equals to OD, OC equals to OD, triangle OCD is isosceles. So we conclude as such. So it should be equals to OCD. Right? Okay, looking at practice number 4, part A, we got this diagram here, okay, and we want to prove that they are congruent. Right? So we extract out the triangles first to compare it side by side easily. So if I were to go for BWX, okay, then I will have WX to to have the double stroke, and then WV to be where the parallel line is. Okay, so WX will have to be XY. We have our Y here, X here, and Z here. Okay. The parallel line doesn't really quite transfer very well. Okay, then now that we have these two triangles side by side already, how do we go about proving that they are actually congruent? How to prove it? One is actually already given. We know Wx is equals to xy, right? Which is given. What else can we derive out of the figures? Yep, Zhiquan. I apologize, I can't hear a single word that you just said. The angle W. Okay, yes. So WXV equals to ZXY because of, what is the property? Yep, vertically opposite angles. So we write that down. WXV is equals to XYZ because of vertically opposite angles. Okay, and we need maybe one more angle. Since we already have one side and one angle, we don't have any information about any other sides. Okay, it doesn't fall in the rectangle or anything. So I cannot conclude that WV will be actually alternate angles parallel lines. So I will say that this and this are equal. Alternatively, I can also say that this one and this one is equal. Yeah. Wait here. Right. X, Y, Z. Okay. Oh, sorry, my diagram here not correct, right? W, X, V, and then we have to have the angle here. So this is the X. And then after that, this must be the Y, this must be the Z. So Y, X, Z. Yep. Oh. Okay. Then after that, we use alternate angles, parallel lines. So we have W, Vx, is here, to be equals to y, z, x equals to this. So we have alternate angles, parallel lines. And we prove that they are congruent by our AAS test. Next one, if I have these triangles, proving that they are congruent. Okay, what do we have to write to prove that they are congruent? Okay, what do you think? Okay, angle BAC equals to angle CDB, which is 35 degrees because it is given. Question also gave that angle BCD is equals to CBD. Sorry, BCA equals to angle CBD. As they are given. Now that we got two angles going on already, we will need one more side in order to use AAS test. So where is the side going to come from? Let's see, how would you prove that the side? BC, what about it? BC, then you just write BC. How? BC equals to CB, okay, why? Because it's overlapping, so we say that we can say BC is common. Okay? Or of course you can also say BC equals to CB bracket common. Alright, but we can simplify it writing it this way also. Then we will say that triangle ABC is congruent to triangle DCB because of our AAS test. Now 5, right? How do we go about proving that these two triangles are congruent? What would you have done? And then what would you have done? BC equals to CD. Because of what do you write? How do you know BC equals to CD? Can help out? It's given, right? Okay, so we just write given. Okay. But then, right? Is B and BC and CD actually corresponding vertices or not? Okay, we are not sure unless we check it out by putting our triangle side to side. Okay, so I have my BCA in this manner. Okay, so to fill up the corners, I will see that this corner here has to be D because it is in between the single line and double line. Then this corner has to be C and down here has to be E. Okay, so we see that actually it should be BC equals to DC. Right? Then I also have AB to be given as equals to ED because it is given. Okay. Then what's the last thing that we will use to prove it? Yes, Joseph.
Angle ECD
Equals to angle
ECD.
ECD because vertically opposite angles. But then, although we got two sides and one angle, this does not satisfy SAS test. So we cannot say that it is SAS test, right? Then how? Yeah, Dylan? We use RHS test, okay? Because we got a right angle, this very importantly is the right angle. And we are looking at hypotenuse AB and ED, okay? So we write down this as hypotenuse. And we have the other side. So right angle, hypotenuse side. And we have proven that triangle ABC is congruent to triangle EDC because of RHS. Okay, and then after that for part B, we are given this rectangle looking shape here. Okay, but we're given this information that WZ is equal to XY. Okay, and then after there are right angles here. We cannot assume that it is a rectangle if the question did not say so. Okay, although we can actually go about proving that it is a rectangle, but nonetheless, we will just keep to the information that has already been given. Okay, so we want to prove that triangle WZX is congruent to another triangle, which we check it to be, this is angle YXZ. So WZX is congruent to YXZ. Okay? How should we go about proving it? We write down the things that have been given. We are given that angle ZWX equals to angle XYZ, which is 90 degrees. And we are also given that WZ is equals to YX. Okay. In order to use, we got one angle, one side. We can resort to using angle, we can use a SAS test, okay, to actually do it. So if I want to use SAS, I must say that WX is equals to YZ, but then we got no information about that portion. So then what should we do? What test should we use? Gina, what do you think? We use RHS, and where is the H going to come from? XZ. Okay, so why is XZ equal to each other? Why is XZ equals to ZX? You want to say that? Because it is in common. So XZ is common, and that is the hypotenuse. Okay, so therefore triangle WZX is congruent to triangle YXZ due to RHS. turn to page 307 of your textbook. We just do a quick run through. You don't want to go for proving it. Since we have already understood the test, okay, let's look at 3A. Taking a look at it, is it a congruent triangle? Are the two triangles congruent? Are the two triangles congruent in this case? Yes or no? Joshua, what do you think? No. Why no? Because Sorry, can you repeat that? Okay, because AB is 8 meters and ED is 9 meters. Okay, so clearly from this diagram here, right, we see that they are not congruent. Reason because we have a pair of sides that are not even of the same length. Okay, so therefore there will not be any corresponding sides. Not all corresponding sides are of equal length, so they are not congruent. Okay, what about part B? For part B, do you think it is congruent? Chloe, what do you think? Are the two triangles in part B congruent? No. Why? If I remember the 4 tests that we have, right? Okay, that we have on the whiteboard here. Which test will it not be able to satisfy? As long as it doesn't satisfy one of the tests, that means it will not be congruent anymore. So earlier on in question 3A, it does not satisfy SSS test. So in part B, what test will it not satisfy? SAS, okay? SAS will not be satisfied because if I have the 40-degree angle here, in the left triangle I have 6 millimeters and 3.9 millimeters here. But then for the other triangle, I have a 6 millimeters and a 4 millimeters. So the 4 millimeters and 3.9 millimeters is the problem such that we cannot prove by SAS test. Okay? Then part C. Alright? For part C, are they actually congruent or not? Answer, what do you think? Is part C going to be congruent? Yes? How do you know yes? Angle TSU is equals to 75. You sure? So they are not congruent, okay, and that is because angle TSU is not 75 degrees, right? This angle here is in fact 85 degrees if you do your calculation, okay? So we find that 5 cm is here, we have 40 degrees and 85 degrees, and whereas 5 cm here we got 40 degrees and 75 degrees. So we are not able to fulfill the AAS test in this case. part D. Okay, are these two triangles going to be congruent? Kelly, what do you think? No, why? MO and PR are not equal in length. Okay, so the hypotenuse itself, okay, are not equal. So it will not satisfy the RHS test. We do have the right angle. We do have one side that is common. But the problem is that the hypotenuse itself are not equal in length. So it fails the RHS test. Okay. So in question 3, all the triangles are not congruent to each other because it failed one of the tests. Okay. Now, going back to exercise 9A, question 6. Since I'm on the visualizer, I shall capture this. Okay, so we are given this diagram here, and GH is equals to JI. Okay, maybe let me draw it clearly. GH is here and JI is here, and question also says that GI is equals to JH. Okay, we want to identify a triangle that is congruent to GHI. Okay, so GHI is a triangle that looks like this. Alright, and prove that they are going to be congruent. So likely we will use the other triangle HIJ, although I don't know whether the vertices match or not. Let's just put in the information here first. Okay, question says GH is equals to JI. So if I have my J here and I here, it matches, and then after that I have my H over here. Okay, question also mentioned that GI and JH are equal in length, and then this angle here is 60 degrees. So I transferred the information into these two separate triangles already. How would I go about proving that they are congruent? How would I do that? Anyway, what do you think? Let's state the obvious first. GH equals to JI because given. What else? GI equals to JH because given as well. So we got two sides already and we need one more. So the thing that we are going to resort to is either the first test or the second test because that involves two sides. Okay, then what is the final one to determine that they will be congruent? So Linghui, will you use SSS test or SAS test? I will need one more side in order to prove this SSS test. Otherwise, one more angle to prove SAS test. So what will your choice be? SAS. Do you know whether the corresponding angles are equal? We know this 40, but do we know this is 40 or not? 180 minus 60 minus 40 gives us which angle? Now you want to change SSS test? Okay, can how am I supposed to say that HI is equals to IH? Under what conditions or why is it that we got these two sides to be equal? Why are they equal? common. Good. Okay, so HI equals to IH because it's common, right, between the two triangles. So therefore, the two triangles GHI and triangle JIH are congruent due to your SSS test. And then part 2, we are given that angle HJI is 60 degrees and GIH is 40 degrees. To find angle GHI, which is here, okay, we will use angle sum of triangle because only after we have proven that they are congruent, then we can transfer the fact that angle HJI is 60 degrees over to this angle here. So what we will say is that since triangle GHI and triangle JIH are congruent, angle HGI will be equals to 60 degrees. Therefore, angle GHI is 180 minus 60 minus 40, and we are left with 80 degrees after using angle sum of triangle property. Okay, so with this question, we are done with chapter 9.1. Homework will be question 4B, D, and F. 4B, D, F, and H. Okay, for the remaining time, I'll just quickly run through and expose you to the 4 different tests for similar triangles. Sorry, 3 different tests for similar triangles. Then we will then call it a day. Okay? So with reference to yesterday's notes, okay, when it comes to similar figures, yesterday we recalled that one will be bigger than the other, but more importantly, similar figures are proportional to each other. Okay, so being the fact that they are proportional to each other, the corresponding sides will have the same ratio. Okay, so corresponding sides have equal ratio. And what we covered when we are in Sec 2 was that the corresponding angles are equal as well. Okay. And because corresponding angles are going to be equal, that is the reason why we have a AA similarity test. Okay, you can call it AAA similarity test, although it is not necessary actually. We only need to find 2 angles, 2 corresponding angles that are the same. The third angle will automatically be the same because after all, we will use angle sum of triangle to deduce that it will be of the same angle. So that is why when it comes to similarity test, AA is sufficient already. Okay, so as long as you are able to have at least 2 corresponding angles, 2 equal corresponding angles, 2 pairs of equal, my English, 2 pairs of equal corresponding angles, okay, it will be sufficient to prove that they are similar. Okay, and in similarity test, the ending statement, okay, the concluding statement, we will end off with AA, or rather the test name, and the word similarity. Okay? For congruency test, we need not write down the word congruence in that test name itself, but for similarity test, we got to write down the word similarity. The reason is because when we see the SSS similarity test, we need to distinguish it from the congruency test that we have for, which is SSS also. The difference in the SSS test for similarity is that we are trying to prove that the corresponding sites are in the same ratio, whereas for congruency test, we are proving that the sites itself are of the same length. Okay, so there is that difference. So what I'm writing over here as a template, right, is that the corresponding sites, for example, PQO here, I realize I must have drawn this wrong. ABC and PQR. Okay. So ABC, AB, and PQ, you can have AB in the denominator, PQ in the numerator, or the other way round is also fine, as long as you keep it that the numerators are always one triangle and denominators are always from a particular triangle. Okay? Dylan, can you please wake up? Oops. What is that? So you've got to ensure that it must be of the same triangle in the numerator or denominator. Then after that, this value k over here is dependent on the answer that we get in the question. Okay, as long as they are of equal value, we will see that they are going to be similar already. Alright. Then after that, lastly, we also have a SAS test for similarity. Alright. Likewise, it must only be SAS. I cannot write ASS. I cannot write SSA because the angle A itself has got to be the included angle. And importantly, we are also talking about the ratio. Okay, so we always find the ratio, the fraction separately, okay, and find and check that they are actually equal. Then we can say that it is the SAS similarity test. Okay, so now that we have 7 tests in total, how am I supposed to remember which are similarity tests and which are congruency tests? Okay, always remember that in similarity tests, because we are trying to find out that the ratios are equal, okay, we need to have at least 2 pairs of ratios, right, to prove that they are equal. Having 1 pair of corresponding sides is not going to help us at all, correct? Because I cannot just find one, then I don't know the other one, I cannot actually end up doing any comparison to say that the ratios are equal. So therefore, when it comes to similarity tests, surely there will be at least 2 S's. Okay. Then for congruency test, of course, that one we also have it now. Okay, we cannot have a single S one. So the only difference is the AAS test. So AAS test is confirmed only a congruency test. Okay, we cannot have an AAS test for a similarity situation. Alright. Then after that, also RHS is definitely a congruency test as well. Okay, any questions? Has my lesson ended? Why are you all happy? Huh? I know I say that this one done with okay, I will dismiss you now. But I haven't said that I will dismiss you, right? Sorry? Okay, since nobody is interested to hear me anymore, right? Similarity test, I will go through the next lesson. Okay, I'll end here for today. Right? What do you look like?